All right, well, welcome back, ladies and gentlemen. We are now in section 6-3, and as you can read the title at the top, it is square root functions and inequalities. And you can obviously glance through and see there's coordinate planes all over the place, so we're obviously graphing. This is really our only graphing unit too in this chapter, so if graphing is not really your thing, you don't have too much to worry about. Not to mention, these are pretty easy to graph overall, so shouldn't really be too much of a problem. But definitions at the top, so I'm actually going to start with radical function. If you have a radical function, basically it's just a function as a radical symbol. Because we can have, a square root, cubic root, fourth root. So if there's a radical symbol, you know that it's a radical function. A square root function is just a type of radical function. In which case, if it's going to be a square root function, you will have a variable basically underneath the square root. So I'm just going to add to this with a variable under the square root symbol. Okay, so your x is basically going to be underneath the square root. So again, if you kind of glance ahead, look at the examples, you will see an x underneath the square root in every single problem. Okay, and that's what kind of constitutes it as being a square root function. All right, so we'll go ahead and get started here. So as you can see, there's already a graph for you. And every single time you graph a square root function, this is what your image should look like. So you kind of see the blue figure off on the right, kind of just makes that little hook, right? And it goes on and on and on forever and ever to the right. But we have the parent function here, so just to kind of refresh what a parent function is. The parent function is basically just the simplest function that we have, okay, where nothing is being done to it. This graph is not being shifted to the left, right, up, down, nothing's happening. It's staying in place, okay? Most oftentimes, actually every single time you have a parent function, it always seems to start at the origin, as you can see here. So again, this is my graph, starting at the origin, continues on forever and ever to the right. So basically, as your x's increase, your y's will also be increasing. Okay? Let's see. So if it's f of x equals the square root of x, another way to write this, you can also just simply say y equals the square root of x. So again, just knowing that y and f of x are interchangeable, okay? Some people just like to see y instead of f of x. But where you get your points from, let me just kind of explain a table setup for you. Okay, so it says right over here that f of x equals the square root of x, and your x's must be greater than or equal to 0. Okay, here's the reason why. Let me explain. Again, the only x's you can choose, so we're just plugging in numbers for x basically, and then solving for our y, but your x's strictly must stay greater than or equal to 0. Okay, so starting at 0. So if you just think about when you plug these numbers in for x, right? 0 is the smallest number I can take the square root of. So when I plug these numbers in for x, I'm taking the square root of each of these x values to help me solve for the y. So if I plug in 0 for x, the square root of 0, well, the y is obviously just going to be 0 as well. Okay, now I have to choose x's that are bigger than 0. So just kind of using my common sense and thinking about when I plug these numbers in for x, I'm taking the square root of each of these values. So numbers that I'm going to choose that would probably make the most sense would be like 1, 4, 9, 16. Okay, because again, I'm taking the square root of these numbers, so why not just choose the perfect squares? When I plug in 1 for x, y is just going to be the square root of x. So y is going to be the square root of 1, which is just 1. And then when I plug in 4 for x, I'm taking the square root of 4, that's 2. Square root of 9, that's 3. Square root of 16, that's 4. Okay, but you can also use other numbers too. You don't have to choose perfect squares. So if I make a different table over here, again, I'll just start with 0. And I know the y is going to be 0, but I can also choose numbers like 1, 2, 3, 4, 5. Okay, as long as they stay bigger than 0, then you're fine. Okay, but again, perfect squares just makes the math easier. Whereas if I plug in these numbers for x, I'm just going to get a lot of decimals. Okay, so here's what I mean. If I plug in 1 for x, again, y is just going to be 1 because it's the square root of 1. But if I plug in 2 for x, I'm taking the square root of 2. Well, I don't know what the square root of 2 is off the top of my head. So if I just go ahead and punch this in, square root 2, as a decimal, it's about 1.4. So 2 is 1.4. Same thing with 3. I know I'm taking the square root of 3 when I plug it in for x. Again, we don't really know square root of 3 off the top of our head. So as a decimal, it comes out to be about 1.7. Square root of 4 we know is 2, but 5, once again, we need our calculator. So square root of 5 comes out to be a little bit more than 2. It's about 2.2. Okay? But again, either one of these options, it's kind of up to you, however you like to calculate your numbers. Okay, you can stick to some easy numbers, just simply plug in numbers bigger than 0, so like 1, 2, 3, 4, 5, or try and get your perfect squares. Okay, if you have something being added or subtracted away from x, though, sometimes it makes it a little bit more complicated, where you have to actually kind of sit down and think about what numbers to plug in to get your perfect squares. But here's the reason why your x's must be bigger than or equal to 0. Okay, so you have to start at 0. You have to start with taking the square root of 0. Okay, you have to start there. That has to be your starting point. If you don't start there, you will be leaving out vital points in your domain. Okay, so like if I just started with 1, I'm leaving out a part of my domain that I actually need. Okay, but I can't do any numbers less than 0, so it says that right here that it's not going to be defined for x is less than 0. So I can't choose numbers less than 0. So if I plugged in like -2, for instance, right? If I plug in -2 for x, if I wanted to choose -2, well, I'm taking the square root of -2. If you take the square root of -2, you know it's going to be an imaginary number. Or you can obviously see in this coordinate plane, we're not graphing imaginary numbers. Okay, you can't graph an imaginary number with a real coordinate plane. Okay, so you can't choose anything that's going to have a negative square root. Okay, you can't be taking the square of a negative number. You will get an imaginary solution. All right? But also take into account the transformation equation, so the transform square root function. We've been kind of reviewing this all year and talking about with almost every graphing unit, but these variables all play a vital role with how it's changing the graph. A does something to the graph, H does something, K does something. So just to kind of refresh what each of these actually do. Okay, so your H value, if you have an H value, what it's doing to the graph is that it's going to be shifting it to the left or to the right. So H, if you think horizontal for H, left or right, it's kind of an easy way to remember it. If it's a negative number, it goes to the left, positive number goes to the right. K moves it up or down. Once again, just kind of making sense. If it's a positive value for K, then it's going to move it up. If it's a negative value for K, it moves it down. Your A value does one of 3 things. It can reflect it, and that's only if it's a negative number. So if A is a negative number out front, then it's going to be a reflection. It also will stretch it, potentially. The only way that it's going to vertically stretch it is if A is a number bigger than 1, so if it's a big number, so if it's like 2 or 3 or 4 or anything like that. Or it can also compress the graph. It could be a compression. So just kind of shrinking it, vertically compressing it, if A is a small number. So if it's less than 1 but bigger than 0, so basically a fraction, so if it's like 1/2 or 2/3 or something like that, something between 0 and 1, then it's going to be a compression. Okay? So we have to graph each function below and then also state the domain and range. Okay, so again, we have to choose numbers for x and then we're solving for the y. All right, but first think about, okay, the first one that we have to start with is we have to start with taking the square root of 0. So choose an x that when you plug it in, you're going to be taking the square root of 0. So the first x value that I have to have, so basically what plus 4 is going to give me 0? Well, that's -4. So I have to start with -4. So now all of my x's that I choose from here on out have to be greater than or equal to -4. Okay? So again, if you want to stick to your perfect squares, you can do that. So kind of like how I showed you up there, but I can't just choose. I can't just plug in, 0, 1, 4, 9. I have to make that number under the square root into those numbers. Okay, so kind of similar to how I made that into the square root of 0 by plugging in -4 for x. So now the next perfect square would be 1, and then we have 4, and then we have 9, and then we have 16, right? So choose the numbers for x that will match these. How do I get a square root of 1 underneath the square root? What would x have to be? Well, x would have to be -3, because -3 plus 4 is going to be +1. How do I get a +4? X would have to be 0, because 0 plus 4 is 4. How do I get a 9? X would have to be 5. 5 plus 4 would give me 9 underneath the square root. And then square root of 16, x has to be 12. Okay, so when you plug these numbers in for x and then solve for the y, again, when you plug in negative 4 for x, y is just going to be the square root of negative 4 plus 4, which again is just 0. So square root of 0 is 0. And then when you plug in negative 3 for x, y is going to be square root negative 3 plus 4, which again is 1. So I'm just taking the square root of 1, that's 1. And then when I plug in 0 for x, I'm taking the square root of 4, which is 2. Plug in 5 for x, square root of 9, which is 3. Square root of 16, when you plug in 12 for x, and that's just going to be 4. Okay, so now you just want to graph it out. We'll kind of see how this looks. So negative 4, 0, 1, 2, 3. Here's negative 4, 0. Negative 3, 1. 0, 2. 1, 2, 3, 4, 5. Going up 3. And that's about all I'm probably going to fit. So 12, 4 is a little bit too big. But again, from your starting point, negative 4, 0, your graph just kind of hooks over to the right and continues forever and ever and ever. Okay? So now, next thing I want to talk about too, what I always see students do as a mistake. So we're kind of used to always having an extension, right? We always have arrows on both ends, typically. So I see students, they always want to go, from negative 4, 0 to the right, but then they also want to go backwards too. But you can't do that in this case. Again, you can't have any x's that are less than negative 4. You can only have x's strictly greater than or equal to negative 4. So if you continue it backwards, now you're including. So if I do continue, I'm including all these x's that are less than negative 4, and I can't have those. Okay? It's undefined for those values right there. But now we have to label our domain and range. So again, as far as my x's go, this is basically your domain. Okay? X has to be a number greater than or equal to negative 4. But let's go ahead and write that in interval notation as well, which would be from negative 4 to infinity, bracket around negative 4. As far as your range goes, where your y starts at 0. From there, if you look at your y's, they just keep increasing forever and ever and ever. Okay, so they don't stop here at 4. They just keep going on, keep getting bigger and bigger. So my range is greater than or equal to 0, which means it goes from 0 to infinity. And that's it. Okay, that's everything all together. But a few things I do want to talk about. So if I go back up here, okay, if you compare this function here to the transformation, okay, technically you have an h value of negative 4. So hopefully you guys recognize that. Again, my h value underneath the square root, h is negative 4, which means in comparison to the transformation, or in relation to the parent function, the whole entire graph, so the parent function again starts at 0, 0. Maybe I'll do that in a different color. So here's my parent function, right? We basically took this graph and shifted everything over to the left 4 units. Okay, I took this whole entire thing, lifted or shifted it over to the left 4 units because h is negative 4. Again, h moves it to the left or to the right. Since it's a negative value, it's shifting it to the left in the negative direction 4 units. Okay, and the last thing I want to talk about with this one, I want to show you in the calculator how this kind of works too. So let me just pull up my TI-30. I can show you in the graphing calculator as well, but if you want to actually see your table of values here, let me just go to table. I already have it typed in, but I can retype it in just to show you guys how it works. So again, I just go to second, square root, I'm just typing in the function. X is right next to 4, so x plus 4, again, that's my function. And now set up your table, I'll hit enter, starting at 0, going by steps of 1, looks good. Okay, so here's my table. This is a table that we just filled out. Okay, we just filled out this XY table. You could see some of the points in common. So 0, 2 is in the middle of the table, and it's the first point I have up here at the top. Let me go back into the negatives and let me show you guys kind of what happens. Negative 3, 1, that's right above 0, 2. We have that point. We also have negative 4, 0. That's the first point. But once I go past negative 4, look at what happens. Error, right? I can keep hitting this all day. I can keep going up and up and up. But you will see that it's just going to say error all the way down because, like I mentioned, you can't have those values, right? I can't have anything less than negative 4 because it's going to be an imaginary number. And there's no imaginary numbers that we can graph on this table or on our coordinate plane. But if I go the other direction, you'll see those other values that we have in our table. So we got 0, 2. What else did we have? We have 5, 3. If I go down to 12, you will see the last point, 12, 4. Okay? And you can also obviously, again, have those extra decimal numbers if you want in between. So even if I just chose numbers instead of doing, -4, -3, 0, 5, and 12, if I just simply went in order, -4, -3, -2, -1, you could do those points as well. Okay, but not everybody likes to graph decimals, so again, I'm just trying to get some perfect squares to get some good, solid, clean numbers to actually go through and graph. Okay, so I just want to show you guys that so you know how to use your table and your calculator. And hopefully you guys believe me now when I say that it's undefined. It does not go in both directions. Okay, so for number 2, the next one. Again, I want to start with choosing an x. What I'm going to do, I have to start with choosing an x that's going to give me the square root of 0. So x in this case, just underneath the square root, ignore the +2 outside. What would x have to be in order to have the square root of 0 underneath? Well, x would have to be -6. Okay, now I have to choose x is greater than or equal to -6. So staying above that, the next one, if you want to do perfect squares again, square root of 1, 4, 9, and 16, we can do that. Okay, numbers you'd have to plug in for x though. If I wanted to have the square root of 1, right, how would I get a square root of 1 underneath here? What would x have to be? It has to be -5. How do I get the square root of 4? X would have to be -2. Square root of 9, x would have to be 3. Square root of 16, x would have to be 10. 10 plus 6 is 16. Okay, now we're going to take these numbers, plug them in for x, and again solve for the y. This one's going to be a little bit different because once we plug them in for x, we have to add that 2 after we take the square root of the sum. Okay, so as an example, if I plug in -6 for x, right? Y is going to be the square root of -6 plus 6 plus 2. So I need to take the square root of this sum first, which is 0. So square root of 0 is 0, and then add the 2, so I get 2 for my y. Now plug in -5. So y is going to equal to the square root, -5 plus 6, which is just 1, right? We forced this to become a positive 1. That was 0, so square root of 1 is 1. 1 plus 2, you get 3. Okay, the next one, plugging in -2, we have -2 plus 6. And that's going to be square root 4, -2 plus 6. So the square root of 4 underneath here, that's 2, and 2 plus 2 gives me 4. And hopefully you kind of notice when I choose these numbers like this to be perfect squares, you'll kind of notice that your y's just steadily increase by 1 each time. So even if I kind of backtrack, if you look at your y's, 0, 1, 2, 3, 4, right? Same thing's happening here, except I'm starting at 2 this time, and then I have 3, 4. The next one's probably going to be a 5. Okay, you should always be looking for these patterns when you're working out your math. So when I plug in 3 now, again, like I said, it's probably going to be a 5, but let's just double check. We have the square root of 9 underneath, which is 3. 3 plus 2 then, what do you know? It's 5. Okay, and then plugging in 10, doing the square root of 10 plus 6, and then adding 2. So square root of 16 is 4. 4 plus 2, you get 6. Okay, so let's graph this one now, and I'll explain this one a little bit more too. So going back 1, 2, 3, 4, 5, 6, up 2. And then going back 5, up 3. Going back 2, going up 4. 1, 2, 3, 4. Then we got 1, 2, 3, going up 5. And then 10, I think I can squeeze this one on. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's all the way at the end here. 10, and then going up 6. So it's kind of going into my work a little bit, but that's okay. But there's your graph. Again, do not make it go backwards as well. But our domain stays strictly, so here's basically our domain. Our x's have to be greater than or equal to -6. Can't go backwards, again, otherwise you get imaginary numbers. Or if you want it, again, interval notation, -6 to infinity. The range for this one, my y's start at 2 this time, and they keep increasing. So greater than or equal to 2. And then from there, interval notation, 2 to infinity. Okay, last couple details here. Again, if you notice in relation to the transformation equation, you have an h and a k value this time. Your h is -6, and then your k is +2. So from the origin, you notice from 0, 0, the entire graph shifted over 1, 2, 3, 4, 5, 6. So that's the -6, so it went 6 to the left, and then it also went up 1, 2. So from the parent function, the whole entire thing shifted over. Even more so, Okay, I might make this a little bit easier on you now. Even more so. Look at the first point in our tables. Negative 4, 0, negative 6, 2, negative 6, 2, negative 4. Basically, your h and your k value is going to be your starting point every single time. If you could properly identify h and k, that's always going to be your first point in your table. Okay, so that might make it a little bit easier. And just know that once you have that first point in your table, you have to choose x is bigger than that number now. Okay, you can't go the other direction. So that's kind of a quick way to go about choosing your numbers and filling out your table. So let's try it that way. Let's go on to the next page. We'll try the next one. So h and k, if you bring these two values together, I'm starting at 2, 5 in my table. Okay, so now I have to choose x's greater than or equal to 2. And again, if you want to, you could stick to the whole approach that we did before. If I plug in 2, that will give me the square root of 0. Now I want the square root of 1, square root of 4, square root of 9, square root of 16. Okay, so how do I make this into the square root of 1? Again, the number has to be bigger than 2, so 3 minus 2 will give me square root 1. So again, I'm just looking underneath the square root here. Think about what I'm plugging in for x. How do I make that into a 4? Well, I have to plug in 6. How do I make that into a 9? That's 11, so getting pretty big here. And then to get 16, that'd have to be 18. Okay, so now plug your numbers in for x, solving for y. If you plug in 3 for x, if you need to, you can kind of work it out on the side here, but if I plug in 3, I'll have y equals the square root of 3 minus 2, and then plus 5. So that's just 1, square root of 1, and square root of 1 plus 5 gives me 6. So again, you'll notice your y's just keep going up by 1 each time. Okay, so pay close attention to that. When you plug in now 6, y is going to equal the square root of 6 minus 2 plus 5. 6 minus 2 is 4. Square root of 4 is 2. 2 plus 5 gives me 7. So there you go, the very next one. And just to make sure our math is coming out okay, I'll just go ahead and plug in the numbers. So plugging in 11, you got 11 minus 2, and then plus 5. Well, that's 9. Square root of 9 is 3. 3 plus 5 gives me 8. And then plugging in 18, y equals square root 18 minus 2, which is 16. Square root of 16 then is 4. If I add 5 to it, again, just increases one more to 9. Okay, so if I plot out these points, just makes that little arc that we should see. But plot out your points going over 2, going up 1, 2, 3, 4, 5. And then we got 3, 6. 1, 2, 3, 4, 5, 6. Go up 7. That's probably all I'm going to fit. Okay, so just continues over and to the right forever and ever. Domain would be, I'm just going to do interval notation, be 2 to infinity with a bracket. Our range starts at 5, and again, they just keep getting bigger. So just be from 5 to infinity. All right, next one. Here we go, h and k. So that's negative 3, and we don't have a k, so that'd just be 0. So negative 3, 0 is my starting point. And again, when you plug in negative 3, that's going to give you the square root of 0. Okay, so again, if you want to stick to this whole routine, we got 1, 4, 9, 16. All right, choose your numbers now. So how do I get a 1 out of that? Again, bear in mind, we're choosing numbers greater than or equal to negative 3. The next one then would have to be a negative 2. To make that into a 4, x would have to be 1. To make that a 9, this would have to be 6. And to be 16, we would need 13. Okay? This one's a little bit different if you notice, because you actually have an a value out front. Okay, that a value, that negative 2. So since it's negative, it is going to be reflected. So it's going to be flipped upside down, and it's also going to be vertically stretched. So our y's are going to be slightly different for this one because we're multiplying by that negative 2. So let me kind of explain as I go. All right, so let me go ahead and plug in the next number. If I plug in negative 2 for x, y is going to be negative 2 times the square root of negative 2 plus 3. Well, again, that's just 1. Square root of 1 is 1. But now I have to take that and multiply it by negative 2. So it's actually going to be negative 2. So it's going to actually skip 2 times each time in between each y coordinate. So watch for the next one. You plug in positive 1 for x. You have negative 2. And then underneath would be 1 plus 3. And again, that's just 4. Square root of 4 is 2. If I multiply that by negative 2, I get negative 4. So again, because we have this a value, now it's being amplified here. It's changing slightly. But you can see our y's are actually going down for 1, and not only that, but they're skipping by 2 each time. So the next one's probably going to be -6, but we can kind of double check. -2, and then we would have 6 plus 3 underneath. Okay, so that's 9. 6 plus 3, square root of 9 is 3. 3 times -2 is, what do you know, -6. Okay, and then plug in the last one, probably -8. Just to make sure my math is correct, this would be 16. Square root of 16 is 4. 4 times -2 is -8. Okay, so graphing this one, we got 1, 2, here's -3, 0. -2, -2. 1, -4. So again, you can see it start stretching. Okay, it's not as slow as an increase as you've been seeing in all the graphs. This one's going to be a little bit more stretched out. Okay, vertically stretched. So 6, -6, I can squeeze that one. 1, 2, 3, 4, 5, 6. And then down 6 would be down here. So here's my graph. Okay, going down and to the right forever and ever. Again, my domain, as far as that goes, here's my restriction, goes from -3 to infinity. Bracket around -3. The range, though, a little bit different this time, right? It starts at 0, but they're actually decreasing. They're going down forever and ever and ever and ever. They'll keep on decreasing the more x's that I plug in. So this would actually be kind of flipped. If it goes from -infinity up to 0 would be my range, bracket around 0. Okay? Now let's get into some inequalities. So square root inequality. Okay, here's the next one. So my h and my k value, 4, -6. All right, so again, this gives me the square root of 0. So now choosing my other numbers, I want 1, 4, 9, and 16. So what numbers do I want to plug in for x to make that into a 1? My x's again have to be greater than or equal to +4. So this would have to be a 5. To get a 4 out of that, let's see, x would have to be 8. 8 minus 4 is 4. To get a 9, this would have to be 13. To get a 16, this would have to be 20. So some big numbers here. Okay, but now just plug those numbers in for x, solving for the y. What we should get in the end, this should be -5, -4, -3, -2. Okay, so graphing it from here, we're going to have 4, -6. So 1, 2, 3, 4. Going down 1, 2, 3, 4, 5, 6. And then we got 5, -5. Oh, it's -7. 5, -5 would be here. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay. But now with inequalities, what we also have to remember with inequalities, square root inequalities, is there's going to be solid or dashed lines. So you got to think about solid or dashed. And then also shade above and shading below. So anytime you see inequalities, you should be thinking the solid or dash and then shade above or shade below. So in relation to my inequality, I know it's going to be a dash line, so you want to dash it, connecting your points, okay? Now as far as your shading goes, when you read that symbol, it says y is less than. Less means you want to shade under. So I want to shade everything underneath, just underneath my graph though. So don't get too crazy with your shading. I just want to shade where my graph is at, just right underneath it. Okay, in that bottom right-hand corner, that is it. That's all you got to do. Okay, so again, that shaded region represents all of your ordered pairs that would satisfy this inequality. So if you plug in any ordered pair in this shaded region, so if you plugged in like, let's see, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. So if I plugged in the 0.7, -6, right? If I plug this in for x, plug this in for y, into my inequality, into the actual square root function, this should actually be a true statement. So if I plug these numbers in, if I had -6 for y, I know it's going to be less than the square root of 7 minus 4 minus 6. So if I actually go through the calculation of this, if I do 7 minus 4, well, that's 3. Now I need to take the square root of 3, and that gives me this number, and then subtract away the 6, that's the last part. It's going to be a number that is going to be greater than -6, because -6 is going to be less than the right-hand side, okay, which it is. -6 is smaller than that decimal, -4.2679, blah, 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 okay? So that's exactly what your shaded region represents. Take any point out of it if you want to. Try another one if you want to, okay, in that shaded region, and it's going to be a solution. The next one, though, is a little trickier. Okay, some of you might be thinking -1, 0 is my starting point. It's not. Okay, the reason why, so if you start with negative 1, 0, right? If you start there again, you're missing some vital points here. If I start with negative 1, that's not going to give me 0 underneath my square root. That has to be your starting point every single time. That's not going to give you 0. So if you plugged in negative 1, you'd have 2 times negative 1 plus 1. Well, that's negative 2 plus 1. That's negative 1. Okay, you're taking the square root of negative 1, which you can't actually do. So instead, here's how you're going to find your starting point. Again, the question is truthfully, what makes this 0, right? What's going to give me the square root of 0 when I plug in a number for x? If you don't know by looking at it, again, this one's a little bit trickier because of that 2 in front. The question is what makes that all 0? Okay, so set it equal to 0, solve it for x. You'd have to subtract the 1 and then divide by 2. We actually have to start at negative 1/2. That's our starting point. And if you plug in negative 1/2 for x, you will get the square root of 0 underneath. Square root of 0 is just 0 for my k value. Okay, so that has to be your starting point. Again, this only applies, truthfully, when you have a number in front of x like we do here. So if it was 3x plus 1 or 4x plus 1, this is what you'd have to do. Okay, now I want to choose numbers strictly greater than or equal to negative 1/2. All right, so choose anything that you want to. I'm not going to be too picky about this one since it is going to be a little bit tougher to actually choose our numbers to make them perfect squares. So I'm just going to make it kind of easy. Bigger than negative 1/2, I'm just going to choose 0, 1, 2, 3. I'll keep it simple. Okay, so now I have to plug these numbers in for x, solving for the y. So y is going to be equal to, when you plug in 0, y is going to be the square root of 2 times 0 plus 1. Well, 2 times 0, 0, 0 plus 1 is 1, square root of 1, you get 1. Okay, now plug in the next one. If I plug in 1 for x, we're doing the square root of 2 times 1 plus 1. Well, 2 times 1 is 2, 2 plus 1 is 3, so now I'm taking the square root of 3. Again, if you need to, use your calculator. It's about 1.7. So here's my next one. Now plug in 2 for x, so y is going to be equal to the square root of 2 times 2 plus 1. So 4 plus 1 is 5. So again, I'm taking square root of 5. That's about 2.2. And the last one, so you can see again your y's are increasing. So 3 should obviously be bigger. If I plug in 3 for x, 2 times 3 is 6. 6 plus 1 is 7. So the last one I'm doing is I'm taking the square root of 7. And that's about 2.6. Okay, so now let's graph this one out. So negative 1/2, 0 is about right here. We got 0, 1, y-intercept. Over 1 up 1.7, over 2 up 2.2, and then over 3 up 2.6. Okay, connecting our points, we want a solid line connecting. So solid connection going over to the right forever and ever. As far as shading, well, this one says greater. And greater means you want to shade above. So I'm going to shade everything above, again, just the graph. Okay? Do not get crazy with your graphing. Do not go all the way across. Keep it in that region. I'll go a little bit faster for this next two. So the next one, we are starting with h and k. So that's going to be negative 2, negative 4. And now we want to choose x is greater than or equal to negative 2. So again, if you want to, you can stick to your perfect squares. I'll just write them next to the side so I can see them. Okay, so to make this into a 1, x would have to be negative 1. To get a 4 underneath the square root, again, just the square root, ignore the negative 4 for now, ignore the negative out front. But to get a 4 underneath, x has to be 2. To get a 9, this would have to be 7, and this would have to be 14. Okay, so if you plug these numbers in for x, solving for y, again, be careful with this one. So when you plug in negative 1 for x, you're doing y is going to be equal to the negative square root of 1, negative 1 plus 2, minus 4. Okay, so you want to take the square root first, tack on the negative, which makes it negative 1, minus 4, so it's going to be negative 5. So again, your y's are actually going to go down each time. They're going to keep decreasing each and every single time because you're multiplying by that negative 1 out front. Okay, you're tacking on that negative. So these numbers will actually keep going down. So if I plug in 2 for x, 2 for x right here, y is going to be equal to the square root, or the negative square root rather. 2 plus 2 again is 4, and then minus 4. So we got the negative square root of 4, which is negative 2, Negative 2 minus 4 gives me negative 6. So again, these just keep going down by 1 each time. So this would be negative 7, this would be negative 8. Okay, so graphing this one out, going down 1, 2, 3, 4. Back 1 down 5. Over 2 down 6. 1, 2, 3, 4, 5, 6, 7, and then down 7. This one we want to dot it 1 again. So you want to dash it, going all the way across. Reading my symbol, it says greater. So y is greater means you want to shade above. So everything above this will be shaded. And there you go. Last one. So our h and k value for this one, we want to start at 0, 4. And now choose x is greater than or equal to 0. Okay. This one makes it kind of easy too. So if you look at the problem, we're just taking the square root of x and then adding 4. So 0 is my starting point, making this 1, 4, 9, 16. Well, if that's the case, again, we're just taking the square root of x and then we're adding 4 afterwards. So I'm just going to choose 1, 4, 9, and 16. So when we plug these numbers in for x, the square root of 1 plus 4, that'd just be 5. Square root of 4, which is 2. 2 plus 4 gives me 6. So they keep increasing by 1 each time. So if I plug in 9, square root of 9 is 3. 3 plus 4 is 7. And then square root of 16 is 4. 4 plus 4 is 8. So you can see it just keeps continuing that pattern. So now graphing this one, 0, 4. There's 0, 4, 1, 5. We got 1, 2, 3, 4 going up 6. It'll be right here. And then over 9 will be right here going up 7. So this one's going to be solid line connecting. And as far as shading for this one goes, reading my symbol, it says greater again. So greater means that you want to shade above. So everything above this will be shaded. And there you go. Okay, so there's your square root functions as well as inequalities. So hopefully this wasn't too bad for you. I think it's pretty easy. And again, you can always use your resource. You can always use your calculator. This can always help you, type it into the table. You can get most of your table out of there as well. Okay, but sometimes you have to adjust your step to actually see all the points that you need, but you can always use that. Or if you have the TI-84, again, where you type it into here, you go to y equals, and then you just go from there. So if it's y equals the square root of x, for example, if you want to see the graph, okay, there's the actual graph, but you have to go to second and then graph to actually get your table. So once again, you can see all those error buttons, error, 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 all the way down. And then you got all these x's and y's. All right? So hopefully you found this pretty beneficial. You can come back and visit this video anytime. Come to your teachers if you guys have any questions on anything. Otherwise, have a great day.